This is the Lshs Geometry Unit 3 Review Number 1. Question number 1 says that I need to find the measure of all of the angles of this triangle. So the first thing I'm going to do is write an equation to add all three of these to equal 180, because the angles in a triangle always add to 180. Once I set up this equation and solve for x, then all you need to do is plug it back in to each angle and find out how much each angle is. So when I do that, I get that x is equal to 16. You can see the work over here. I combined all my like terms, and then I added 44, and in the end I got x is 16. So to find all of the angles, all you have to do is substitute 16 in for x. So I'm going to go ahead and do that real quickly. So in the end I got the three angles. One of them is 79, that would be the largest one. The smallest angle is 48, and then the medium angle is 53. And if they asked you to describe this type of triangle, because all three angles are different, it's considered scalene. And because all the angles are less than 90, it is acute. If one of the angles had been 90 degrees, then it would be a right triangle. And if one of the angles was more than 90, it would be an obtuse triangle. Question number 2 says we need to find the value of x in the parallelogram and then find all the missing angles as well. So the first thing that you should know about these two angles, which are sometimes called consecutive because they are next to each other, they add to 180 degrees. And the reason why that's the case is because if it's a parallelogram, then these two are parallel, and these angles are really called same side. So I'm going to solve for x first. So when I do that, I get that x is 8, and now I'm going to substitute in 8 right here to find out how much that angle is. So one moment. So this angle right here, which is acute, is 58 degrees, and then they want all the other angles. So hopefully you also know that opposite angles in a parallelogram are the same amount. So this is 58. And then the other missing angle must be 122. This says WXYL is a square. So what's important about a square are several things. First of all four sides are equal. And we have 90-degree angles at the corners. And I'm not sure if you know, but in the center there's also 90 degrees. And the diagonals bisect each other. So they told us from P to X, this is 7x minus 1. That's from here to here. And P to Y, that's this one here, is 2x plus 11. Well, it turns out they're exactly equal in a square. So to solve for x, I'm just going to solve this equation, setting them equal to each other. So I just wanted to double check one more time. The question was to find the value of x. So we set those equal, and when I did, I got either this fraction, 12 divided by 5, or 2.4 as a decimal. Either answer is acceptable. Question number 4 says we have a quadrilateral PQRS that has diagonals, PR and QS, and it says it has two pair of parallel sides. So parallel, remember, looks like railroad tracks because they never intersect. So those are parallel and these are parallel. So this is one possibility. Now they ask us to choose all that it could be. So basically we're looking for what shapes have two pairs of parallel sides. And hopefully you know that a square definitely does. Square looks like that, and it has two sets of parallel. So does a rhombus. A rhombus is basically a square that's kind of slanted, so it has two sets of parallel. A parallelogram is the one I originally drew. That definitely has two sets of parallel. A rectangle, sort of like a longer square, also has two sets of parallel. A trapezoid. Trapezoid looks kind of like this. And actually it is not, because it only has one set of parallel. So this one is not. And a kite, well, you might think that it does, it has two longer sides here. And this side is not parallel to this. They would eventually meet. So a kite is not. This says given quadrilateral math is a parallelogram. So they're telling us it's a parallelogram at the beginning. And what they want us to prove right here is that triangle ATE, now I'm going to erase these in a minute, but ATE is that triangle, is congruent to HME. And then we have to fill in all the information. So I'm going to start at the beginning with a proof. And hopefully you know with all proofs, you need to mark what they give you. You have to start with given information and then try and make connections to get to the end. So it tells us it's a parallelogram, that's number one. So the reason I know that is because they gave it to us. That's right here. And hopefully you know in line 2, those symbols mean that they're parallel. So I'm going to mark AT is parallel to MH, and AM is parallel to TH. And the reason is no longer given. The reason is actually the definition of a parallelogram, because all parallelograms have opposite sides that are parallel. The next part says, in a parallelogram, opposite sides are congruent, and AT and MH are equal. So they're kind of telling us this in the proof, that these sides are equal, and they told us the reason. The next part says, the reason is that if lines are parallel, then alternate interior angles are equal. Well, what we need to look for are our alternate interior angles. And I think I just marked two things wrong. This says AT and MH. So let's see if I can erase some of this. Oh, I can. Good. So I'll put back the parallel. And then they said that AT, that's this side, is equal to this side. So now I have the angles, and I'm looking for alternate interior. Well, if I follow this Z right here, then hopefully you can see that that angle and that angle would be equal because they're parallel. So I'm going to say angle ATM is congruent to angle HMT. And you are allowed, if you want to put numbers. So if you would have wanted to put a 1 there and a 2 there, then right here you would have just said that angle 1 was equal to angle 2. Sometimes that's a little easier. The next thing they told us is that angle AET, that's this angle, is congruent to HEM. That's this angle, and hopefully you know that's because they're vertical. And all vertical angles are equal to each other. So now if I'm looking at my picture, and if I separate my triangle just a little bit, I'm going to separate the bottom from the top. I have that these are equal. I have that this angle and this angle are equal. I have that this angle here, because the vertical was equal, so these triangles are congruent by AAS. Question number 6 says, given that we have a parallelogram, state all the properties of the sides and the angles. So if it's a parallelogram, which is kind of like a rectangle that's slanted, then we know that XY is congruent to WZ, and XY is parallel to WZ. So we have that opposite sides are equal and they're also parallel. And then the other sides, XW is congruent to YZ, and XW is also parallel to YZ. And then the last part talks about the angles. Well, angle, you can either call it angle A and C or X and Z, it doesn't matter. I'm going to say that angle X is equal to angle Z. I'm also going to say that angle W is equal or congruent to angle Y. And I know that angles next to each other like this, which are called consecutive, add to 180. So I could say that angle X plus angle W equals 180. You could say the same thing about Y and Z. Angle Y plus angle Z is 180. And we could say that about several others. I'll just list one more. I could say that angle X plus angle Y also add to 180. In question number 7, it says use triangle FCD below to answer the following question. And the first thing I notice about it is that this is 5 and this is also 5, which means A is the middle of that side, and the other side has 7 and 7, and that is also the middle. So this segment right here is called the mid segment. And one of the theorems that you should have learned about the mid segment is that it is parallel to the bottom segment, which is like this side is parallel to this side, and that's what I'm going to put at the bottom. A, B, and C, D are related, they are parallel. And more than that, the top AB, this length right here, is half of the bottom. So AB is actually half of CD. So now they ask me to find, I know that A to B is 2x minus 1. I know that C to D is 3x plus 2. And what some students do incorrectly is they just set an equation equal to them. But what we need is we need 2 of these to equal the bottom. So I'm going to solve 2x minus 1 plus 2x minus 1 equal to the bottom segment 3x plus 2. So when I do that, I get that x is equal to 4. And all my work is over here on the right. They then ask me to find the actual length of AB. So then I'm just going to plug 4 back in. 2 times 4 is 8, minus 1 is a 7. And the bottom, if I plug a 4 in here, I get 3 times 4 is 12, plus 2 is 14. Oh, and since the bottom is double, I know that I solved it correctly. This question says we need to find the area and the perimeter of the figure below if all the line segments meet at right angles. And basically that means we have rectangles. So the first thing I notice is this is 7 and this is 4, which means this length right here has to be 3, because 3 plus 4 will give me the whole bottom. On the other side, I know that this should be a 5, because 5 plus 9 is a total distance of 14. So once I have that, I can find the perimeter very easily. So I'm just going to add starting at the top, and I'm going to go kind of clockwise. So 3 plus 5 plus 4 plus 9 plus 7 plus 14, and I'm going to add that up. So when I did that, I got that the perimeter was 42, which is the distance all the way around. Now they also want me to find the area. So there are several ways to do it. You can divide it down like this into 2 rectangles, and I'm going to get rid of that. That's one option. Or I could divide like this and find those 2 rectangles. And a third option is to box the whole thing in and subtract. But I think for most people they prefer to divide it sort of like this. So if I look at this bottom, this is a rectangle and it is 7 by 9. So 7 times 9 is 63. So the area right here is 63. And then the other one, you have to be careful. The 14 is for the whole thing. So this rectangle is really just 3 by 5. So this is 15 in here. So if we want the total area, we just have to add 63 and 15, and we get 78. So the area is 78, and the perimeter is 42.